Okay, so on the homework, there's 4.9, which is like the most difficult one of the homework. I'm gonna go and just read it. I'm not gonna like give you the answer, but I'm gonna kind of show you how to set it up. So it says, using the die class defined in this chapter, write a class called pair of dice composed of two die objects. Include methods to set and get individual die values, and methods to roll the dice, and a method that returns the current sum of the two die values. Create a driver class called rolling dice 2 to instantiate and use the pair of dice object. Okay, so just from the perspective of what was just described, I'm going to go ahead and kind of just draw this up really quick if I can. All right, so we already have a class called die. Okay, it was defined in the book. It was like one of the first examples that I gave you. Okay, and this die class is a blueprint for a die object. So when you actually instantiate a die object, here's like a die. Okay, the services that it provided was to roll, and you had like your get face value and your set face value. Okay, those were the three services it provided. Was to roll. I don't know if roll looks like, that doesn't even look like an R. To roll, to get, and to set, right? And the instance data that it had was just the face value. Okay, everybody remember that? Okay, so now they want you to define a new blueprint. Okay, so here's your blueprint class, but this is going to be a blueprint for a pair of dice. Okay, so over here we defined how a singular die would behave, but over here we want to define how a pair of dice behave. Okay, so for this one, what we're going to do is we're going to define two die objects inside of this die class. So there's two die objects. Okay, so I know some of you have shown me work where there's like two face values defined in here, and like that's actually like the wrong way to do it according to the instructions that were provided in the book. So what you actually have to do is come over here and have instance data for like a die, like, and you call this one like maybe like die 1, and then have another one here like die 2, right? Then you have your getters and your setters and the methods that it describes in here. So some of the methods it wants you to have is to include methods to get and set individual die values. So you're gonna have like a setter called set die 1 face value, and one called set die 2 face value. Then one called get die 1 face value and get die 2 face value. And then I want you to provide a method called get sum, and that's basically going to add the two die face values together and then return the result. And then it wants you to have one called roll, and that's just going to roll the two die objects, right? So what do you think the roll method in the pair of dice class would actually do? Would you say call the? Okay, so it's not actually going to randomly generate anything because the roll method for an individual die. Oh dang! What the heck?
You call the method in the die class, right?
Exactly, right? So there's already a roll method defined in the die. So over here, if we were to define roll, right? This roll is actually going to be something like this. It'd be public, right? And then void roll. Right, and then open, close, all right, and then you're gonna say like die 1 dot roll, or whatever your instance data is, right over here, like whatever you named it there, and then die 2, right? There's the die 2 right there, dot roll. These are methods, right? So it's basically, so this pair of dice class is essentially just a blueprint for a class that manages two die objects, right? It's actually pretty simple. Right, but so in total, like if you actually want to get this to compile and run, you're going to need this class right here, right? Here's one Java file right here. This is a .java, and then you're going to need this .java, and then you're going to need the driver class, which it wants you to name rolling the dice to, right? You're going to have another class called rolling dice 2 job, right? This is going to be the one with the main method that instantiates a pair of die object and pair of dice objects and calls its methods, right? So you can have your rolling dice 2. So you can actually have 3 files: that one, this one, and this one right here. Okay, any questions on that? Did that kind of clear up some of the confusion? Yes.
Could we, the pair dice class, could we include that in the die class, like in the same file?
Wait, what do you mean?
Like instead of having 3 files, could we just
No,
use 2?
don't have 3 files. So this is already defined. It's not asking you to recreate this. If I don't know if you guys bought the book, but if you did, there should have been a CD maybe. I don't know if it came with the CD that has the dice or the die class already written. If it doesn't, then you can go to my Dropbox folder and then go under demos. And if you look under chapter 4, I'm pretty sure I already did this one all the way, right? So you could just use this one. It does the exact same thing as the one from the book, right? It has a TwoString, it has a roll and the getter and setter for face value. This is like complete. So you could go take this file, put it to wherever your pair of dice class is at, so that because they're going to work together, and then you're going to write your driver class for your pair of dice. Okay, so your pair of dice class is going to manage 2 die objects. All right, does that make sense, or is anybody still kind of confused on that?
I got a question. When you say get the sum of the two dice rolls, how would you print the results or like get the results? Would you create a variable results and then kind of
So in your die or in the die class, we defined a method called get face value. Okay, so if you have 2 die objects, how would you sum up the value of the face values?
So you would get face values of both dies and then just add those together.
Right. Okay. So that's exactly what you do. You just return the sum of those 2 die face values added, like whatever the result is, you just return it from the method.
When we return it, we can just return dice 1 get face value plus that, and that would be the method get or whatever the method name would be.
Yeah, you can write it one line where it just says get sum and it's just return die 1 dot get face value plus die 2 dot get face value. Yes.
So would this be basically copy pasting what you put down for set face value and then just making a new object that says set face value 2?
You're not really copying and pasting this. You're actually just what I'm saying is you need this in order to create those die objects.
So for both die, you would only use one method?
No, you would actually have 2 methods.
So it would be written just like that one, but you would replace set face value 1 with set face value 2, and you would use that fourth value for your second die.
Right. So like according to the instructions for this pair of dice, so this is here's your pair of dice. Right, here's the class, right, pair of dice. Okay. According to the instructions, right, you have your header right there, and then you have your instance data. Your instance data is going to be 2 dies, right? So you're going to have like a private die and then like die 1, right? And then private die 2, so on, so on, so on. Okay, so I want you to create a setter for each die, right? So you're basically, this is the way this is going to work, is you're going to say public void, and then set, and then you can do like face value, blah, blah, right? But somewhere in here, you're going to have like die 1 inside of the setter because you're going to have to do the exact same thing for, oops, I didn't mean to do that. I can erase with this. You have to have the exact same thing. Right. Here, okay. All right, so what do you think you would have to do in this setter, right? So, I mean, you're still going to have to take in, oops, God dang it. I'm trying to get used to this. Erase, dang it. Okay, there you go. All right, what do you think you're going to do? Like here, you're going to take in an int, and it's going to be like the value that you want to change it to. So what do you think you're going to do inside of your set face value die 1? Like, what are you going to do right here?
Just value equals val.
Okay, so if you go back to your die class, you've already created a set face value, right? So you don't have to like reinvent the wheel here. Really, all you got to do is just get your die, whatever die you're setting, like die 1, and then call set face value.
Okay.
And then you just pass it this value right here, right? Whatever came in, you'll just pass it right there, value. That's supposed to be the tip of an arrow.
And then when you do the same for die 2, it's going to look different anyways, because the way that the method was created, it'll have like a different result every time.
Well, I mean, for die 2,
Most of the time.
it's going to be identical, except this is going to be different, right?
Uh-huh.
And then instead of doing it on die 1, you're going to do it on die 2. Okay. So, yeah, the pair of dice is just managing 2 die objects. It's like collectively grouping 2 dice or 2 die and then saying this is a pair of dice, right? Like they each die behaves the same way, but they can contain a different face value, right? So the object, the idea of an object for a pair of dice is basically just, like you always using 2 die, right? So a pair of dice, you can pick them up, right? You can roll that pair of dice, and you can get the sum of the face values of the 2 die that are showing. You can, if you wanted to set the face value in a pair of dice, you can pick it up and set it to whatever value you wanted, right? If you wanted to get the face value for one of the dice, you can look at the die and you can visually see the face value. That's the get, okay? And we already described the roll, right? Picking it up, and the sum is just summing them together, right? So this is basically like grouping the 2 together and just kind of calling their methods, right? So you don't want to like reinvent anything here. Like there's nothing unique that you're gonna do except for maybe the sum method where you just sum the 2 face values together. All right, does that make sense?
Yes.
All right, is everybody clear on that?
Why would you need to set the face value whenever that information was set in the die class?
They say it again?
Why would we need to set the face value whenever that was set in the die class?
Because the die class, or the pair of dice class, is now the manager of 2 die objects. So now you need to provide a service to set that face value, even though you're just going to call set face value on it. I don't know if that makes sense, but like the way to think about it, at least the way I visualized it. Let me see. Let me go back over here.
So I guess would we need to set face value to get the sum of the value, or can we just like?
You don't need it, but you need to invoke it because the instructions tell you to create the object and test its methods, right? So you want to actually invoke, right? So here's a die. Here's another die. Dang it, what the heck. All right, so here's a die and it has like it's certain behaviors, right? But together, these are kind of like in a group, okay? So here, you're providing the service to set the face value for die 1, okay? And what this is gonna do, oh dang it, I didn't mean to do that. And what this is gonna do is essentially just call, right? This method here is just basically gonna call the set on this die, right? And when you have set die 2, it's gonna call set on the second die, right? Like this is kind of like a class that's kind of encapsulating 2 die objects, and you're providing new services now that says set face value for die 1, set face value for die 2, get face value for die 1, get face value for die 2, get sum, and roll, which is gonna roll both the dies. Okay, makes sense? All right, so I want everybody to do that one. I mean, I think there's a lot of good lessons to learn from that problem. Yeah. All right, so I'm going to go ahead and continue. So like I said, we're going to continue in chapter 4, but not really continue in chapter 4. I'm just going to go over some topics that I'm going to test you on your final exam that weren't actually covered in chapter 4. They're actually covered in chapter 7, but chapter 7 there's like a lot of other things that Chapter 7 talks about that I don't want to go into. So I'm not actually going to read slides. I'm just going to talk about a few concepts. So there's like at least 3 or 4 different concepts that we need to cover over the next, over this week. Okay, so one of them is overloading. We're going to talk about overloading. And that is a definition that you're going to need to know. You can look it up in your book. It's basically just creating a new method for the same method, but it has the same method name, but the parameter list is different. And it's basically, you just call this, it's almost like you're calling the same method, but you're passing in different values, and they do different things. It'll make more sense once I talk about it. The other thing we're going to talk about is overriding. And we've already kind of talked about this. So when you override, we override the TwoString method. Okay, another method that we're going to override in chapters 5 and 6 is the equals method. You need to know the difference between the two, right? So when you override, you're actually creating a method on your class that is going to take the place of a method that was defined on a parent class or a base class. Okay, now we haven't talked about inheritance, but every class that we create in Java inherits from a class called object. So we get all of those methods on the object, and those are what we're going to override. Okay, the other thing that we're going to do is that we're going to create utility methods. So we have classes that we use for blueprints. We have a driver class. You can also have a utilities class where you just have methods defined just to perform some odd task. You don't want to actually make it part of a class to where you have to have an object of that class. You just want to just be able to call it. We're talking about utility methods, and the other thing we need to talk about is Java docs. But I think I'm going to just have you guys read something and then give you guys a quiz on it or something. Yeah, I'll see how far I get. But if I don't cover Java doc, I'll probably just give you guys like a reading and then have you do some homework on it or something. I don't know. I'll figure it out. But let's go ahead and talk about some of these. So just to kind of go over the whole inheritance thing. So like I said, every class that you create inherits from the object class, and I'm going to go ahead and just kind of demo that again. I have demoed this before with the TwoString method, where if you don't define a TwoString method, then what actually happens is the underlining base classes, the object classes TwoString method is called. Okay, all right, so the first thing I want to do is, the reason I had this up is because I want to make this account class, okay? Just so I think it's a good class to kind of demonstrate some of these concepts. So I'm going to go ahead and make an account class, and some instance data that we're going to have on the account is the account number, the balance, and the name. Okay, so with that, I'm going to go ahead and create this class. All right, and I'm going to go ahead and save this. And I'll go ahead and put this in chapter 4. Or should I put it in a different folder? I'll put in a new folder just so you know that it's after the bit term. Like chapter 4.2 or something like that, yeah. All right, and I have a class called account. It is a Java file. Now this is gonna be a blueprint class, so that just means I'm creating this class in order to create objects from it. So I'm going to have public class account. All right, and then some of the instance data I said I'm going to have is an int. Was it an int? I can't remember. Was it a long? Oh, it was a long for account number, a double for balance, and then a string for name. So I have account number. Okay, I'm gonna go ahead and just make getters and setters for this data. I'm not sure if the book actually does that, but I'm gonna go ahead and just do that. So I'm gonna say public void. I'm not gonna do that yet. Set account number. And I'm going to go ahead and take in, oh, you know what? That reminds me, the other thing I need to talk about is this reserved word. All right. So public void set account number. What the heck? What am I doing? Set account number. And then we're going to take in a long, and then we're just going to call this like number. And then we're going to say account number is going to be equal to the number that is passed in. I'm going to just copy this, paste it. Okay, so public void set balance. Okay, we're going to take in a double because our instance data was declared to be a double. And we're going to say balance is equal to the balance that's coming in. And then set name. And then we'll say name is equal to the string that was passed in. All right, and then I'm going to go ahead and make getters for this data as well. So public, and the first one's a long, so I'm going to return a long. Public long get account number. I'm going to return account number. Public double get balance. Then public string get name and return name. All right. Okay, so I defined this class. So right now I have instance data for the account number, the balance, and the name. And then I just made like some getters and setters for all this information. I'm going to go ahead and just get rid of this space right here so it kind of like doesn't take up so much room. All right, I'm going to go ahead and make a test class or driver class to test this object. So I'm going to come over here and I'm going to create a new, and then I'm going to go to File, then Save As, I'll call this one Account Test. All right, so it's going to have the main method. So I'm going to say public class account test, and then public static void main string array arguments. Okay, so I have this class that I just created, and it has instance data for account number, for balance, and for name. I haven't defined a constructor, right? So if I haven't defined a constructor, that just means I get a default constructor with no parameters. So I can do something like this: account one is equal to new account, right? There's no values passed in the constructor. And then I wanted to define, to say I wanted to make two accounts. Account 2 is equal to new account. Okay. Now, right now, I don't have any, I didn't set any data, so it's just going to be stuck with whatever Java decides is the proper data for all of this. So normally for, or actually always for numbers, it's 0. And then for string or anything that's an object, it's going to be defaulted to null. Now, if I were to say system.out.println and do something like this, account 1, and then print out account 1, what do you think is going to happen? Nothing. Yeah, exactly. So there is no TwoString method defined. So when Java comes over here, it's going to look for it. It's going to say, hey, there's no TwoString method. So it's going to invoke the method on the underlining object class, right? So it's not specified up here, but every class that you create, if you do not specify a parent, it actually extends from the object class, right? So it's like if every class we create actually has that attached to the class header. Okay, in this case, it doesn't because it's something that Java doesn't require us to do. So if we do not inherit from a class, then we're just going to automatically get whatever the object class has defined on it. Okay, and one of the methods it has defined on it is the TwoString method. So I can actually invoke the method TwoString, and you would think that it would not compile because I don't have it defined over here anywhere. But if I go ahead and compile this and run, you can see that I do have an output where you have class name and then you have this hex value right here, right? So if I do the same thing for account 2, I'm going to get the exact same thing.
Why does that print out like that again?
Because this is the, because every class that you create actually inherits from a object class. So if you do not define a TwoString, it's going to call the TwoString method on the object class, and the TwoString method on the object class prints out the class name and its location in memory. Okay, so we didn't actually override our TwoString, right? So it didn't actually do what we normally expected to do when we do override our TwoString, right? I never defined a TwoString method on my account class, so when I do print it out, this is what I get. Okay. All right. So now let's go ahead and just, because my TwoString method is not defined, I'm going to go ahead and define that. So I'm going to just hop over here, and I'm going to go ahead and create a TwoString method that overrides my object's TwoString method. So it has, the headers have to match. So the header on the actual object class is public string TwoString. Okay. And now what we're going to do is just return some type of string that it represents our object in some way. So I just want to know the current state of my object. When I say I want to know the current state of the object, that just means I want to know what the current values of my instance data is. All right, so I'm going to come over here and I'm going to return a string. I'm going to use string.format. I'm going to say I want a string that is going to have the class name and then have account number, and that is a long. I wonder if I can get away with using %d on a long. I don't know. I'll find out. All right, and then the balance, and that is %f, and then also the, actually maybe I should put the name first. You can see the name on the account. The name, the account number, and the balance. Okay, so now I'm returning a string that is going to give me all those values. So I'm going to go ahead and put the variables that I want to put in place of the string, the integer, and the floating point value. So I'm going to say name, account number, and balance. All right, to save that, hop over here, move this up, compile, run. All right, you can see that the values for account 1 and account 2, I never actually set the name, so it's null. The account number is 0 because it was never set, so that was the initial value that was given to it. And then you have the balance, which is a double, which is also 0, so it's 0.000000. All right, any questions so far?
The longest time I thought on that TwoString method, I thought you had to like concatenate, like that stuff where
You can concatenate, but this is a method that you can call on the string class. I did talk about this, I'm sure.
I think I was.
Yeah, so that's really not my problem.
That's my fault.
Okay, so
I'll love string format.
yeah, so I like it too because you can just, like, you see your string how you want it set up, and then you just put like these little indicators of where you want your data injected. So the %s is for a string, so the name gets placed right there. The %d is for an integer, so this long value gets inserted right there. And this f is for a floating point value, so your balance gets put right there.
Do those have to be in order after that comma? Or
Yes, they do. All right, so that is what happens. Okay, so I'm going to go ahead and call these setters. Or did somebody have a question? I thought I saw a hand go up. No? All right. So now what I want to do is I want to go ahead and give my account some data. So I'm going to go ahead and say, okay, I'm going to go ahead and set my name, and I'm going to set account number. I'm I'm going to set balance. All right. All right. I do need to pass in data, so I'm just going to say Mike for the name, the account number. We'll just say the account number is 1,
That's not realistic.
and the balance is.
You work for a bank.
I'm just testing this right now. Okay, so I'm going to go ahead and print my values out. I'm going to put the same data in for account 2. Okay, and I'm going to print the values out, and you're going to see that the values are in fact printed out. Maybe I'll just change one of these names to like Tom or something like that. All right, I'm going to compile. I'm going to run, and now you can see the second time that I print out my data, right? You can see that the data was able to get set from the call, from the setter calls. All right, now I'm going to go ahead and change the account name from Tom back to Mike. And then I'm going to call this new method, or I don't want to say it's new, another method that exists on the object class that we're going to start using since we're going into chapter 5 and 6. And I'm going to ask the question, does account 1 equal account 2? Question mark, space. And then what I'm going to do is I'm going to say account 1 dot equals account 2. Okay, so they both have the same data, right? And I'm calling this equals method. This equals method exists on our object class. So like I said, even though we do not specify it, every class that we create in Java actually inherits from a underlying class called object. So it's like having this up top. So on the object class, there is a method called TwoString, and there's a method called equals. Okay, so I don't actually have an equals method defined in my account class. So the underlying object class is going to invoke its equals method. If I were to compile, it does compile. That means that the equals method is a valid method on my account object. And when I go to run, you can see that account 1 and account 2 are not equal to each other, even though the data is exactly the same. Okay. So what's actually happening in the object class's equals method is it's basically checking to see if they're the exact same object in memory. So what that means is it's checking to see if they're both pointing to the same location. All right, so if these are object reference variables of the same thing, then this is going to return true. If I come over here and I make a object reference variable called account3, and I set account 3 equal to account 1, this means that both account 1 and account 3 are pointing to the same object in memory. Now if I were to check to see if account 1 is equal to account 3, then you'll be able to see that they are equal to each other. So I come over here and I ask the question, does account 1 equal account 3? And then account 1 equals account 3. I pass in, it's going to compare the two to see if they're equal. And now you can see that that comes back as true. Right. So account 1 and account 3 are equal to each other only because they both are object reference variables to the same object, right? By this assignment right here. Right, this is what we call aliases. So both account 3 and account 1 are pointing to the same object. So they don't have their own data. It's like basically having two variables represent the same object. If you change something on the other, we're both going to see the same change because they're both pointing to the same object. Right, so the way to visualize this, we did talk about this in chapter 3, I believe, but I'm going to just talk about this one more time. So here's your memory right here, and account 1, when you instantiated it, okay, like just say got placed like right here, right? So account 1 is now this object right there, and account 2, when you instantiated it, say it's pointing right here. Then we created account 3, but we didn't actually create an object. We just assigned account 3 account 1. So what Java's actually saying is, oh, now you have account 3 pointing to the same location that account 1 is pointing to. So a setter call on account 3 is going to actually call a set method on the same object that account 1 is pointing to. Right? So they're both actually pointing to the same location, and this is what we call an alias. Alias. Is that the way you spell it, or is it I before the A before the
I
I?
got a question. So what kind of functions what does that do?
It just makes the same reference to the same object. I mean, it doesn't really do anything unique. I mean, you just have to be careful, right? If you do something like that they're both pointing to the same object. Yeah. I don't really think I've ever used an alias for anything except for a split second of wanting to create a new object but putting it into a temporary spot to like hold it, right? So I put it somewhere else, and then like the other variable, I'll assign it some other value or some other object. But for the most part, like you do want to try to avoid making aliases because it's considered to be like dangerous, I guess, because a change on one is going to affect the other, right? Unless you know and you intend for that behavior to happen. Yeah. Okay. All right, so let me think. There's so many things that we need to talk about. All right, so now what I want to do is I want to go ahead and override the equals method on the account so that my equals actually does something other than check to see if they're the same object in memory, like we did here. Okay, so me personally, I feel like if the account name's the same, the account number's the same, and the account balance is the same, then this is probably the same object, right? But in all reality, to me, right, if the account number is the same, right, because the account number should actually be unique, then I would say it's the same account, right? So if the account numbers match, I would say it's the same account. Okay, the way you override this is similar to the way you override the TwoString, is you have to copy the exact header. So we're going to say public, and you're going to return a Boolean value. The equals method returns a Boolean. You type out equals because that's the name of the method. But the equals method actually takes in an object, okay, of the object class, and it does its comparison, okay? So what that actually means is you can actually pass in any object into the equals method and do a comparison. So let me go ahead and just comment this out real quick. Wait, I can't comment out like that. Let me go ahead and just delete this really quick. Save it, and just to show you what I mean, let's just say if I made another object, and I'll call this one, I'll make a string object, right? So, not name, but I'll just say like pet.
What?
Yeah.
I like bank name.
This I'm showing examples of. Okay.
Gotcha.
All right. So if I come do a comparison, does account 1 equal pet? You can actually pass in. Oops. I'm going to do that. You can actually pass in your string that you named pet into the equals method because the object class takes in a generic object. Okay, so it's still going to do the same comparison though. It's going to check to see if they're the exact same object. So this is going to return false, right? It still compiles and it runs and all that, but obviously these two objects do not equal each other because one's an account and one's a string, right? It returns false. All right, so I want to override the equals method. So I'm going to copy the exact same method header, and now I have to come up with a way to actually do my comparison. So one of the things, something new that we're going to do is we're going to check to see if the object coming in is an instance of the account class. The way you do that is just take your object that came in. This could be any identifier, right? We can just say O if you wanted to, right? Or because this is a parameter in our method, right? If whatever name we put up here, we have to use within the method. I'm just going to stick with the object. Okay, so I'm going to check to see if my object is an instance of, and there is a reserved word called instance of, and I'm going to check to see if it's an instance of the account class. Okay. Now this is going to filter out anything that's not an account and anything that is null. So filters anything or any object that is null and or not an account object. All right. Okay, so I basically filtered all that because null is technically, you know, a placeholder for an object. So if you can do equals and compare it to null, and you'll get the it's going to do that check to see if it's the same object in memory, and you should get false if I were to pass any null right here. All right, I'll go ahead and I'll test that. In fact, let me just Control X this really quick, save it, and then add that test so we can see all the different tests. So does account 1 equal null? And I'll just pass a null. Compile. It compiles, and then run. And you can see that that is false. Right? Because a null is valid data for an object reference variable. It just means it doesn't point to anything. So we do have to handle null whenever we're looking to compare or check for equality. All right, so that's what I have right now. Equals, you pass in an object, and then I'm going to check to see if it's an instance of an account that filters out null and filters out anything not an account object. Yes?
If you didn't specify any values, would it be null? Like if you did equals null, didn't specify any values, would it come out as true?
No, because you can't invoke a method. Oh, I see what you're saying. Okay, so the question was, if I didn't call my setter right here, would it still be null? And the answer to that is no, because the object still exists. It just doesn't have data that's been updated. Okay, so this is good. This is a good question. So let me just Control X this one more time, or Control Z. Wait, I don't want to do that. Dang it. Control Y. Okay. Control X, save, hop over here. The question was, if I got rid of this, would this account equals to null return true? And the answer to that question is no, because it's not null. Account 1 is not null, right? So it's false. And it's not null because the object still exists in memory. It's just its instance data hasn't been set to anything valid. Now, another thing is, if something is null, then you can't actually invoke a method on it because it's nothing. Does that make sense? Like if I came over here and just said, right before I did all of these equals, and I just said, you know what, let's just go ahead and make account 1 equal to null. Okay? It's not going to compile because I'm invoking, actually it will compile, it's going to be a runtime error because I'm invoking methods on something that is null, right? So if I compile, it does compile, and I run, if you can see the exception that we got, null pointer exception, and telling us line 17. Here's line 17. And the reason why is because we called equals on an object that is null because it's not an object. You can only call methods on objects, right? And account 1 currently is not an object because it's null. Does that make sense? Okay. All right, so hop back over here. All right, so now what we're gonna do is we're gonna just think of all the things that we would want to be equal in order to say these two accounts are actually equal to each other. Okay, so we're just gonna compare all the data. Okay, so yeah, I mean, it's simple. It's just as simple as just returning 3 checks, right? The first check is to see if name is equal to the name being passed in from the object. Dang it, actually I messed up. Let's go back over here. Now I have to convert this object into an account object. Now because I know that it is an instance of the account, I can go ahead and make a object reference variable for an account, right? And I'll just call this one other account. or other, and that's going to be equal to my object casted to an account object. So over here, I'm just forcing this object to be an account object now. I already checked to see if it is an instance of, so Java's going to be okay. Like this will not throw an exception. So now I can do things like, you know, if the amount or account number of this is equal to the other dot account number, okay, then if it's true, then I know that the account numbers equal to each other, and I can do like more checks inside of here and continue on, right? So that's why we have to force this to be an account object so that Java knows what data and what methods exist on that object. Okay, so what I'm gonna do is let's see, there is a object though, so all right, I'm gonna have to go back to it later and explain it, but I'm gonna go ahead and just do my 3 comparisons. The first one is check to see if this name is equals to the other dot name, and if this account number equals the other account number, and this balance is equal to the other balance. Okay, so I'm getting the balance, the account number, and the name from this account, this other account, just by referencing the variable, right? That this data is being declared as private, right? I declared it as private, but I'm able to get it just by invoking or calling the actual instance data. Does anybody know why that's possible? Like why don't I have to use the getter and setter? Like if I go to compile, it compiles except I missed a return. So out here I'm going to return false. So basically if none of this is true, then you're not equal to the object. Okay, compile. Okay, it does compile. So how come I don't have to do get balance here and get account number for this other object? All right, the reason is because I'm actually in the account class, right? So only the account class can reference your instance data directly. So even though it's for another object, since this method is inside of this class, it can actually reference this data right here without having to call get account number or get balance, right? So I'm basically just checking to see if my name, this account's name is equal to the other account, this account number is equal to the other account number, and this balance is equal to the other balance. If all of these are true, and we'll talk about what all this means in chapter 5, okay? But if all this is true, then I'm going to say the 2 counts are going to be equal to each other, and I'm going to return true. Otherwise, I'm going to return false. All right, so now when I come over here, since all this data is in fact matching, when I go to compile and run, you can see now account 1 and account 2 are now equal to each other. Okay, and the reason why is because I overrode the equals method to actually check to see if the names are equal and the account numbers are equal and the balance are equal. Then I go ahead and say that they're equal to each other. If I were to change one thing on these, like just say I put like instead of a 5.6, I have a 5.16 on one of the accounts. When I compile and run, you can see that account 1 and account 2 are no longer equal to each other. It returns false now, right? So if this is actually working for me, this check. Now there is, this is gonna actually crash if I were not to initialize data. If I compile and run, I get a null pointer exception. It's telling me there's a null pointer exception on line 37 of account. If I go to line 37, my null pointer exception is here. And the reason why I got null pointer exception is because of that name dot equals, right? I'm calling this equals method on something that is null, right? Name is null, so there is no method equals on this object. It's not a string. There's several things you can do. I believe Java actually has a string. Let me try this. String dot equals, and then you just pass in name and other name, and it's going to return true or false. I believe it's there. I can't remember what language this is for, but that doesn't work. Dang it. No suitable. I thought. Okay, maybe it was like a third-party class. Let me go ahead and go to string, Java API. Click here, and then search for equals. I thought I had a static method called equals. So what's static? So here are some static value of. Dang it, there is no. I guess it was just like a third-party library that I'm thinking of. There's a format equals ignore case. All right, dang it. All right, so I'm gonna hop back over here. So what we're gonna have to do is we're gonna have to check to see if those are null, right? So what I'm gonna do is like control Y. So I'm gonna do is check to see if this is null first, and then compare, right? So I'm gonna say if name equals null and other dot name equals null, or wait, if name equals null. Let me think about this. All right, so basically I don't want to call this method if both of these are null, or if this is null. Otherwise, this is going to throw an exception. So I need to come up with a way to prevent that from happening. So I'm going to say if this is equal to null, then what I want to do is, we'll learn about this operator in chapter 5. I'm going to say this is equal to null, then I don't want to invoke this method. I just want to check to see if other dot name is equal to null. Otherwise, I want to do this check. Yeah, this check right here. All right, I think that should work. It does so far. Okay, so hop over here, compile, run, and account 1 and account 2 are equal to each other, and I went ahead and I handled the null case. So I checked to see if it was null first. If it is null, then I just check to see if other is null. If that's going to be return true if it is equal to null. Otherwise, I'm going to do this check right here, and we'll talk about this, what I did right here in chapter 5 or 6. I can't remember what chapter we talk about that. Any questions so far? I noticed like kind of a lot because we're talking about things that we haven't learned to use yet. So it might seem a little foreign right now, but we're like by the end of chapter 5 and 6, we're going to have to write equals methods for our classes. Okay. So I know we haven't talked about this, what I did here, or like what the equal signs mean, or the double ampersand, but we'll get to all that. But right now, what I really just wanted to show you was that we have this equals method that we override on our object class for any class that we create. Okay, so we have the TwoString, and now we have the equals method. Any questions on those? No? All right, so let me see. Let me hop back to what I was supposed to talk about. Okay, so that's overriding. I just talked about overriding. Now I want to go ahead and touch on the topic of overloading. Okay, so if you go back to here and you kind of look at through some of these methods that they defined, like a deposit. Okay, so they have this method called deposit, and basically it's like you're putting money into your bank account. So you have this method called deposit, and what that's going to do, it's going to go ahead and add money to your account. So it's going to take whatever amount you deposited, and it's going to add that to whatever your current balance is. It's going to say balance is equal to your current balance, right, plus the amount. And then what we're going to do is we're going to return back the balance. You can see what the new balance is. I'm going to go ahead and do the exact same method on my account class. gonna hop over here, go to my account class, and I have my getters and my setters defined up here. So I'm gonna go ahead and add a new method, and this method is gonna be called deposit. So I'm gonna say public double deposit, and this is going to take in a double for the amount that you're going to deposit. And what this is going to do is just say this, whatever your balance is, it's now going to be equal to whatever your balance is plus the amount that was added. And then you're just going to return whatever the balance is so you can look and see what your new balance is. Okay, it's real simple, it makes sense, right? You add money to your account and then you look at your balance and you have money there. All right, so I'm going to go ahead and make a new driver for this. I'm just going to copy this. Actually, I could just do save as, right? File, save as, and then just change the name. So this is going to be account test 2. Dang it, and it's saved as a text file. Mother fudger. All right, so save this as, what's that? So account test 2, and I forgot to set this to Java source file. I'm going to save it. All right, that looks better now. Looks happy. Okay, so account test 2. So I'm going to add the 2 right over here. I'm going to go ahead and I only need one account to show overwriting. Dang it, hold on. I need this though. So all right, then I printed it out there, and I don't need to do any of this stuff anymore. Okay, so what I'm going to do is I'm going to go ahead and make a deposit, and then we'll see what what gets returned when I make a deposit. All right, so right now I have $5.16. So I'm going to do something like system.out.println. Say balance after $10 deposit. All right, and then I'm going to say account 1 dot deposit, and then I'm going to put in $10. So this method does return a value, so that's why I can just concatenate it to a string, because there is a double value coming back. So I'm going to compile this, and I'm going to run. I've deposited $5, or excuse me, $10. You can see that I now have $15.16, and just say if I made another deposit this time for, I don't know, $3, compile, run, and now it's, oh wait, I did 3, but I forgot, I didn't update this method. Compile, run, and now it's $18.16. Okay, I'll just say I made a deposit, but this time I went to an ATM, right, that wasn't affiliated with my bank. So now if I wanted to deposit, I don't know, like $56, can you deposit money at ATMs that aren't?
Supposedly.
Yeah, you can.
Yeah, you can.
Okay, let's say you go to a different bank and a different bank charges you a fee, I guess. I don't know. I don't want to have to write a withdrawal method right
I
now.
don't do it often because the first time I tried, it malfunctioned.
Oh, that sucks.
Jacked all your money.
No, I mean, that's why I did it one bill at a time.
But
Yeah.
are these $100 bills or?
No, 20s, but, yeah.
All right, so I'm going to deposit $50, okay, but I'm going to say balance after $50 deposit at random ATM. Okay, I'm still calling the same deposit method, and you can see that it deposited $50. It didn't charge me a fee. The reason it didn't charge me a fee was because there was actually no, like, it was just me printing out that I deposited $50, right, from an ATM. Now, if I wanted to actually simulate there being a fee for using this ATM to deposit, what I'm gonna have to do is come over here and do what we call overload my deposit method, right? So I just copied and pasted the deposit method, okay?
Is this because of the fee?
All right, because now I want an amount, but I also want a fee associated with it, right? So now what I'm gonna do is have a new method, or not a new method, it's the same method name, but the parameter lists are gonna be different. This one takes in one double, this one's gonna take in two doubles, and
It can automatically discriminate which one is which based on the values you input.
right, so if you use the one that takes in one double, then it's going to use this method. If you pass in two doubles, then it's going to use this method right here. All right, so now when I go deposit $50, I can say, you know what, there is a $2 fee for using this ATM. So the 2 here is going to go right here on this fee, and it's going to get subtracted. Right? And now I'm going to get the balance of there being the amount added, but also the fee on top of that. All right. So I'm going to go ahead and save this, compile, run. All right, and you can see that I deposited $50 right here. Right, so that should have went to $68.16, but it actually went to $66.16. Right, so that's what we call overloading. Now you have to be real careful with this too, because I mean you could make an overload like this, right? So you could look at the way that I work this, right? When I deposited 10 and 3 and then 50 and the 2, I actually use what Java considers to be an integer literal, right? Does everybody agree with that? A double literal actually has the decimal point on it, right? So if I came over here, I can actually override this deposit method, okay? But I can say, you know what? I'm going to take in the amount as an integer and not as a double, and now Java's going to use this method instead. Guess.
Can you tell me the definition for overloading once more?
Overloading, actually I don't actually know the definition on the top of my head, but if I had to give you a definition without looking at the way that the book describes it, but I'll go ahead and look at the book and give you what it says. It's creating a method with the same name that performs a different task and has a different parameter list. I know that seems like a bunch of words I just made up because I'm just seeing it from my mind, but let me go ahead and just look at the definition in the book really quick.
Seems like it's a parameter within a parameter.
Parameter within a parameter. What? That's super confusing.
Yeah.
Okay, I thought there was a gloss. No, dang, I am blind.
I mean, I kind of get it. So it has the same name so that depending on what conditions are different within it, it'll go to that one instead of the original.
Right, exactly. So as long as the parameter list is different, it can have the same name. It's going to execute a different method. Anybody know what appendix the glossary? Oh, here it is, appendix A. All right, so from the book, because this is where the test question is going to come from. Let's see, element OP, right? Okay, overloading, okay? So this is what it says in the book, okay? So overloading, assigning additional meaning to a programming language construct, right? I guess that's super technical. So I would say assigning additional meaning to a programming language method. But you know, this is like in general. That's why it was confusing, because this is like all programming languages. Because in other language, you could overload operators, you can overload, okay? But it basically, method overloading is supported in Java, but operator overloading is not. Don't just totally forget we talked about operator overloading. Like in C++ and those languages, you can actually have an operator do something different, like the plus sign or the minus sign. Do something different when you're doing that to two objects, right? Like if you have an account and you're adding two accounts together, you can override the add so that it can do something different than what the normal add would do. So the definition is assigning additional meaning to a method. Okay, I guess that's, if you're going to put it in terms of Java, assigning additional meaning to a method. Right, it's the same method, right, because it has the same name, but now it's doing something different. Now for an integer, right, if you give me an integer, what I'm going to do is I'm going to add in the amount. Let's say I'm going to just subtract amount because I made an error like in my code. So whenever they give me an integer, I'm going to subtract amount from the balance and then give them return back their balance. Okay, just from some coding error that I made, I didn't do it intentionally. Now, when I hop over here, all these are integers that are actually being passed in to the deposit method. So when I compile and I run, you can see that the values were subtracted, right? Because Java saw the 10 as an integer. So when I hopped over here, it was like, okay, well, which one do I use? Do I use deposit with an integer or do I use deposit with a double? You know what? They gave me an integer, so I'm going to hop over here and use this one where I subtract the amount. Okay. If you were actually to enter in a double, then I would just do like a 0.0. And now when I deposit $10, you can see that $10 actually does get deposited. But then when I went to deposit the 3, it used the 1 for the integer. Okay. So you got to be careful with those because as long as the parameter list differs, Java will see it as a different method, right? So these two are different because the parameter list takes it in here and a double here, okay? So when you actually do pass in a integer literal, it's going to call a different method. I mean, it could be desired behavior, like maybe you want to do something different when they enter in an integer, but maybe not. I don't know. Up to you. Okay. Now you can do the exact same thing with your constructor. Okay, so that was the other thing that I want to talk about. You can overload your constructors. So I have not actually created a constructor yet, but if I were to create a constructor, I would say public account. I would take in no parameters, and then I would say the account number would be equal to, I guess, 1 maybe, I don't know, 0, who knows, we'll just say 1. And then the balance we'll just say is 0, right? That's a good number to start off with. And the name, instead of having null, we'll just say it's a bank, right? So maybe have like a little note in here that says no name given. Okay, so now whenever you create an account object, that's going to be your default data. So when I compile and run over here, you can see that that's what I have right there. Okay, and that was me creating an account object with the constructor that takes no data because I made my constructor take no data. Now I can overload my constructor, which is something that is done a lot, and you are going to do this more often than probably overloading a regular method, is overload a constructor. Okay, so just say this is what I want to do when they pass no data into the constructor, but let's just say they do know their account number, right? So they're going to give me a long for account number, and they're going to give me a double for balance, and they're going to give me a string for name. So they should probably move the name in the front. I don't know. To me, it makes more sense to have the name in the front. Okay, and then what I'm going to do with this data is I'm going to assign name to name. I'm going to assign account to account. I'm going to assign balance to balance. Okay. Right. There's this ambiguity here of what account number it's using, what, right? All that, it's confusing. But I just want to go ahead and just demo something with that too, because it's going to bring up another good point that I want to talk about. Okay, so account 2, I'm going to give it the name of Bob, and the account is going to be account number 2, and the balance is say Bob deposited $100, and I'm going to go ahead and print out account 2 right here just by simply passing it to the system out print line, compile, run. Okay, you can see that Bob name is null, his account number is still 0, and his balance is still 0.000. Now what actually happened is when I called this constructor in fact did get called, right? But because the name in the parameter list matched the names in the instance data, Java only saw this as you assigning this instance or this parameter that you passed in to equal to itself. Like you didn't actually assign the instance data, right? It got this confused Java, and basically it said, okay, the account number coming in is equal to itself, the name coming in is equal to itself, and the balance coming in is equal to itself. It did not actually change any of your instance data. Okay, so this brings up a problem of what if I was absolutely dead set on using name and account number and balance. I didn't want to change it to, maybe change this to an N or change this to number and different to BAL. I didn't want to do that. You can use this operator. This helps Java distinguish what you're talking about, right? This means this current instance of, so you're saying the current instance of the account number is equal to the account number coming in. The current instance of the balance is equal to the balance coming in. The current instance name of this account is equal to the name that is being passed in. I'm going to save this and come over here, compile, and I'm going to run this. And now you can see that that data actually stuck this time, right? So that is this operator, and that is also overloading a constructor. So I created a constructor that takes in 3 parameters, the string, the account number, and the balance. I could keep going, right? Just say if all you knew was a customer's name, then maybe I just want an account number that can be constructed from just a name alone, or this account number is going to be equal to 1 and this balance is going to be 0 or something like that, right? Maybe not 1. I think if you're actually, I don't know, maybe this should be like -1. I don't know, to kind of bring some significance to it not actually being set properly. Because if I do 1, that's going to match what I did over here on the constructor that takes no data up top. I don't know. It's up to you. You're the programmer, right? Hop over here. I'm going to create another object, this time account 3. But this time, I'm not going to pass in an account number or a balance. I'm just going to pass in a name, and we'll just say Tammy. Compile and run, and now you can see that account 3 I didn't actually print out, so let me go and do that. So account 3, oops, account 3. All right, so now you can see that account 3 has a name, has the account number, and has a balance, right? Where the balance is 1 and the balance is 0. The account is 1 and the balance is 0, right? Because that's exactly what we did in the constructors, okay? So this is called overloading your constructors. Now you have 3 different ways to create your object. You can keep going as long as the parameter lists aren't the same. So what that means is I can't come over here and make this again, where you have a string, a account number long, and a double balance, right? Even if I change this to like ASDF and then slap this right here, right? Java's still gonna see that as the same thing. And if you go to compile this class, it's actually telling you the constructor string long double is already defined. So it wants you to come up with a different parameter list for this constructor that you're trying to overload, okay? So it's actually looking at the data type of the parameter list. So when you overload, the parameter list has to change. Or does that make sense? All right, cool. All right, so there is a few more things I'm gonna talk about, but I'm already getting tired of talking. My mouth is getting dry. The utility methods, that's actually pretty cool. It's basically just creating methods that actually just do some task for us that don't require us having an object. So I'm gonna go and stop now and not give you guys a quiz or anything, but next class, I'm gonna talk about a few things, and then I'll hit you guys with like a quiz where you have to overload and override and use utility methods and use the this operator, that type of thing. All right, any questions? All right, that's it. Have a good evening. All this is on Dropbox. This account test. Dang it! I saved it the wrong thing. Right? I meant to save it. Wait, did I save it the wrong thing? Yeah, I did. I overrode what I did before. All right, I'll fix it. That's a good thing about Dropbox is you can go back and look at what you previously had saved.